Now the second example that we are going to consider is a Fourier series of the function which is defined in the interval minus pi to pi. So let us consider this example. Find the Fourier series of the function f of x equals to defined like this: minus pi for minus pi less than x less than 0, and it is x for 0 less than x less than pi. Hence deduce that pi square by 8 equals to 1 upon 1 plus 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus and so on. So in this example we see that the interval of definition is minus pi to pi. So the Fourier series of the function f of x in this case is given by a0 by 2 plus summation n varies from 1 to infinity an. Here the interval is period is 2 pi, so L is pi. So here cos n pi x upon L means cos nx plus summation n varies from 1 to infinity. Again this is Vn into sin nx. So one by one we will calculate a0, n and Vn. Now a0 is given by 1 upon pi integral minus pi to plus pi f of x into dx. This f of x is defined for minus pi to 0 and 0 to pi differently. So we split this integral accordingly. So this integral will be integral minus pi to 0. In that interval f of x is minus pi into dx plus integral 0 to pi. In this interval the f of x is defined as x. So it is x into x. Solving these integrals and simplifying, we will find 1 upon pi. This is minus pi x within the limit minus pi to 0 plus x square by 2 within the limit 0 to pi. So putting these limits and simplifying, we get 1 upon pi. When you put upper limit here, minus pi into 0 is 0, and minus when you put x equals to minus pi, that becomes minus of minus pi into minus pi is pi square. Okay. Plus when you put upper limit here, it is pi square by 2 minus lower limit is 0. If you simplify this, you will find this is 1 upon pi into minus of pi square by 2. That is, this is minus pi by 2. So a0 is minus pi by 2. Let us calculate area. So a0 is minus pi by 2. Okay, I will write that here. A0 equals to minus of pi by 2. Now we will calculate an. An equals to 1 upon pi integral minus pi to plus pi f of x cos nx into dx. That is equals to 1 upon pi integral minus pi to 0 minus pi into cos nx dx plus integral 0 to pi. So f of x equals to minus pi for minus pi to 0, and it is x for 0 to pi. So it is x into cos nx into dx. Solving these integrals, we'll find it is 1 upon pi minus pi into cos nx minus pi. Integral of cos nx is sin nx upon n within the limit minus pi to 0 plus integral of x cos nx. We can write this as first function x, integral of cos nx is sin nx by n minus derivative of this x is 1 into integral of sin nx upon n is minus of cos nx upon n square. So here complete the integral within the limit 0 to pi. So putting the limits and simplify, we find 1 upon pi minus pi. When you put upper limit, sin 0 is 0 minus when you put lower limit x equals to pi, sin n pi is also 0. So this term vanishes. Plus here when I put upper limit pi, sin n pi is 0 minus minus plus cos n pi is minus 1 raised to n upon n square. This is the upper limit minus lower limit. When you put x equals to 0, this term vanishes. Minus cos of 0 is 1 upon n square. So if you simplify this, you will find this an equals to 1 upon pi bracket minus 1 raised to n minus 1 upon n square. This is an. Let us calculate bn. Bn is given by 1 upon pi integral minus pi to plus pi f of x sin nx into dx, which is equals to 1 upon pi integral minus pi to 0 f of x is minus pi into sin of nx dx plus integral 0 to pi x into cos nx into dx. So solving these integrals, what we will find? 1 upon pi minus pi. Integral of sin nx is minus of cos nx. Minus pi into minus of cos nx upon n. Okay. Within the limit minus pi to 0 plus integral of x cos nx. First function x, integral of cos nx is sin nx upon n. Sorry. Which is equals to 1 upon pi integral minus pi to 0 minus pi into sin nx dx plus integral 0 to pi x into sin nx dx. Solving these integrals and simplifying, 1 upon pi we get minus pi integral sin nx. Integral of sin nx is minus of cos nx upon n within the limit minus pi to 0 plus integral of x sin x. First function x, integral of sin nx is minus of cos nx upon n minus integral of x is 1. Again integral of this bracket is minus of sin nx upon n square. within the limit 0 to pi. Put the limits and simplify. 1 upon pi okay, this is an. What is an? So I will write final value of an here. Rest of the thing I will erase. An is 1 upon pi minus 1 raised to n minus 1 upon n square. Okay. Now continue our calculations. So Bn, this is equals to 1 upon pi. Put the limits minus pi. When I put x equal to 0, cos of 0 is 1 minus 1 upon n minus, and this minus will become plus. Cos of n of minus pi means cos n pi is minus 1 raised to n upon plus. Here when I put upper limit, this is pi, cos of n pi is minus 1, so minus of minus 1 raised to n upon n, minus and minus, this will become plus. Sin of n pi is 0, so this term vanishes. Minus lower limit, when I put x equal to 0, this vanishes, and here sin of 0 is 0, so lower limit is 0. Simplify. So after simplification, what I will find is 1 upon pi. Here pi and this pi I can cancel it. Okay, so minus 1 upon n. Again here if I take minus common, this is 1, so 1 minus 1 raised to n plus, here pi will get cancelled, and this is minus of minus 1 raised to n upon n. Finally 1 upon n, the 1 minus 1 raised to n minus 1 raised to n. So finally it is 1 upon n, the bracket 1 minus 2 times minus 1 raised to n. So this is our Bn. So with these values of a0, an and bn, now we are able to write the Fourier series for the given function f of x. So f of x, the Fourier series of f of x is given by a0 by 2 minus pi by 4 plus summation n varies from 1 to infinity, an is minus 1 raised to n minus 1 upon pi n square into cos nx plus summation n varies from 1 to infinity, bn. Bn is 1 minus 2 times minus 1 raised to n upon n into sin nx. So this is required Fourier series. Now to get the required deduction, we put x equal to 0 in this equation 4. So we get f of 0 equals to minus pi by 4 plus summation n varies from 1 to infinity minus 1 raised to n minus 1 upon pi n square. Cos of 0 is 1 and plus sin of 0 is 0, therefore that term vanishes. So f of 0 is this one. Let this is equation number 5. Now if you recall what we have defined f of x in the given example is like this. F of x equals to minus pi for minus pi less than x less than 0, and it is x for 0 less than x less than pi. That means this f of x is not defined at x equals to 0 in the given example. So in that case what we do, we find f of 0 by taking the limit of average of the limits of f of x from left and right as x tends to 0. That is 1 by 2 limit of f of x as x tends to 0 from left plus limit of f of x as x tends to 0 from right. Now if you see, when x tends to 0 from left, means from this side, at that time value of f of x is minus pi. So limit, left hand side limit of f of x is, as x tends to 0, is minus pi. When x approaches to 0 from right hand side, the value of f of x is x. So in that case, the limit of f of x as x tends to 0 from right hand side is 0. So the value of f of 0 is minus pi by 2. So put this value of f of 0 in equation number 5. We get minus pi by 2 equals to minus pi by 4 plus summation n varies from 1 to infinity minus 1 raised to n minus 1 upon pi n square. Simplifying this, what you will find, I will take this minus pi by 4 on the right hand side, left hand side. So this is minus pi by 4 equals to this 1 upon pi I will take outside. The summation will, n varies from 1 to infinity, minus 1 raised to n minus 1 upon n square. Now take that 1 upon pi on the left hand side and simplify again. We will find minus pi square by 4 equals to summation. Now I will put n equal to 1, 2, 3 and so on. So when I put n equals to 1 here, minus 1 raised to 1 is minus 1, minus 1 minus 1 is minus 2 upon 1 square. Okay. When I put n equals to 2, minus 1 raised to 2 is 1, 1 minus 1 becomes 0, so 0 upon 2 square, and that term vanishes. When I put n equals to 3, minus 1 raised to 3 is minus 1, minus 1 minus 2 upon 3 square, and so on. You will get these terms. Simplifying this, you will find pi square by 8 equals to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus and so on. Taking minus 2 common from these terms and take on the left side, we get the required deduction.